Now let us see another question in which we have to find the value of I naught. So as you can see, it is given that this I naught is a current which is flowing through this 3 ohm resistance, and there is a point where two elements meet, but this point is not a node. So we can say that this given network is not planar. Okay, this is not planar. And remember, I told you that we cannot apply mesh analysis for a network which is non-planar or not planar. So the very first task will be to convert this non-planar circuit to a planar circuit or planar network. Okay, we have to convert this into a planar network first. Let me call this as, say, node A. Okay, this as node B, this as node C, and this as node D. You see that these two are same node and these two are also same node. So I have A, B, I have, say, D and C. These are the four nodes which I have: A, B, C, and D. From this circuit, you can see that between A and D, I have a 2 volts voltage source. I have a voltage source of value 2 volts. Okay, it is like this. Between A and B, I have a 2 ohm resistance like this. So between A and B, I have a 2 ohm resistance. Between B and C, I have a 3 ohm resistance. So this is a 3 ohm resistance. Between B and D, I have a 2 ohm resistance. Between C and D, there is a resistance of value 2 by 3. Fine. Are we done? No, we are yet not done. You see that we have how many elements here? 1, 2, 3, 4, 5, and 6. In other words, we can say that we have 6 branches, but here we have only specified 5 branches. So what is going to be the 6th branch? There's something common between A and C as well. So I can write that between A and C, there is a resistance of value 6 ohms. Now this circuit, I can say is a planar circuit. This is a planar circuit or a planar network. And I can apply mesh and node analysis on a planar network. Fine. So we can redraw this in order so that it looks pretty good. I'm sorry. This is going to be like this. I have a voltage source, 2 volts, and then this is directly connected. Then we have between, say, this is A, this is B, this point is D, and I want to have C point. So let me call B और C के बीच में what we have, B और C के बीच में we have a 3 ohm resistance. Between A and B we have a 2 ohm resistance. Between B and D we have a 2 ohm resistance. Between, this is point C, right? Between C and D. So it's going to be something like this. Between C and D, what we have is a resistance of value 2 by 3 ohms. And between A and C, what is there? Between A and C, we have a resistance of value 6 ohms. Fine. So you see that we have reduced or redrawn this circuit in this form, where I can say for safely that this is going to be the reference or the ground. Fine. And as you can see, we have to find out what is going to the value across this 3 ohm resistance. What is the value of current across this 3 ohm resistance? So in a way, it is asked that what is going to be the value of current across this resistance. And we can apply our favorite technique, the mesh analysis, to solve this circuit. Let me call this as mesh 1, IM1, this as mesh 2, IM2, and this as mesh 3, IM3, and all are in impedance representation, and this is a voltage source, so we can safely apply mesh analysis. Although one problem was that it was not a planar circuit, but we have now converted into a planar circuit. So I can now write 4 times Im1 minus 2 times Im2 minus 2 times Im3 equals to 2 volts. That's how we write for mesh 1. Sum of impedances in mesh 1 is 2 plus 2. Anything common between 1 and 2? 1 and 2, so this is 3, right? 1 and 2 is 2, and common between 1 and 3 is also 2. And we have a 2-volt source. For mesh 2, I can write that the sum is 2 plus 3 is 5, 5 plus 2 by 3. So I can simply say that this is going to be something like 5 plus 2 by 3. I am 2. Common between 2 and 3 is 3 ohms. Common between 2 and 1 is 2 ohms. We do not have any source, that's why a 0. Now for 3, I can write this equals to 3 plus 2 is 5 plus 6 is 11. IM3. Anything common between 3 and 2? A 3 ohm resistance. Anything common between 3 and 1? A 2 ohm resistance. And we do not have any source. So you just have to solve for this 3 by 3 matrix system and find the value of IM1, IM2, and IM3. And I last time told you that you can use this calculator to solve this value. This is going to be something like 5, 3 is 15 and 17 by 3. So let me solve this, and you will get the answers to be like minus 2, minus 2, and 2, minus 2. This is 5, 3 is 15 plus 2 is 17 by 3, minus 3, 0, minus 2, minus 3, 11, 0. So my IM1 is 0.869 amperes. IM2 should be something like 0.456 amperes. And IM3 is like 0.282 amperes. Let me just check it. 4 minus 2 minus 2, 2, minus 2, 17 by 3, minus 3, 0, minus 2, minus 3, 11. Okay, so some mathematical errors might be there, but I have doubly checked it. So these are going to be the mesh currents, okay? And we have to find out what is the current across this 3 ohm resistance. Let me call this as I naught, okay? And applying mesh transformation, you can simply say that I naught can be written as Im2 minus Im3. And what is then going to be the value of this current which is across this 3 ohm resistance? What is Im2? 0.456 amperes minus 0.282 amperes. So I can say I naught is equals to 0.456 minus 0.282. So this is going to be about 0.174 amperes or 174 milliamperes. That's how you're going to solve for this particular question. Thank you so much.